Hello guys, welcome back to my YouTube channel. So we would be continuing discussing our top 150 series of questions on Leetcode, and today we are going to discuss our next question, that is substring with concatenation of all words. So let's first see in which companies this question has been asked. So in the last 3 months it has been asked in Google, last is Amazon, Roku, then Media.net, Yahoo, Microsoft, Adobe, Apple, Meta, Bloomberg. So lots of companies are asking this question as well. So let's see what this question states. This is a hard category question. So you are given a string as an array of string words. All the string of words are of same length. A concatenated string is a string that exactly contains all the strings of any permutation of words concatenated. For example, if words is equals to A, B, C, D and E, F, then A, B, C, D, E, F, A, B, E, F, C, D. So there can be any permutation. All these permutation are all concatenated strings. A, C, D, B, E, F, A, C. Like this is A, C, D, B, E, F is not a concatenated string because it is not the concatenation of any permutation of words array. Return an array of starting indices of all concatenated substrings in S. You can return answer in any order. So suppose this is the string given to us. If we start from 0, then bar and foo, these are present. So we can say that this starting substring is a concatenated string. So we will add 0 into our answer, that is the first index. Now if we check this foo, the foo is present but D is not present, so this will not be included in our answer. Then this can be included in our answer, foo and bar. So 9 is also present in our answer. If we consider any other index, suppose we consider this bar and man. So bar is present but man is not present, so it is not a concatenated string. So this is the case. And in example number 2 also, if we see, these are the words, and if we consider this starting word good, best. So word good, but again good is not coming, so this will not work. If we check out this one, then good best word is appearing, but this word is not appearing. So again this is also not a correct concatenated string. So the main purpose, like the main way in which we can check whether a string is concatenated or not. So we will pick a particular index, and we will also calculate what is the total length of this words array. So total length is 16 here. So we will check like up to 16th length only we will check, and by like every word will have the same length. So we will check 4 length word, then we will check another 4, then we will check another 4, and then we will check another 4. So all these 4 words should be present in that, then only it is a valid index with a valid concatenated string, and we will add it into our answer. Similarly, if we consider this, if we consider starting index, so this is 9. So we'll consider only 9 places. So this is bar foo foo and this is bar foo di. If it would have been di here, then it would have been our answer, but it is not present. But if we consider this part, foo bar di, so 6 is our answer. If we consider this part, bar di foo, so 9 is also our answer. And if we consider this di foo bar, so 12 is also our answer. But if we consider this foo bar, but man is not present, so 15 is not our answer. So in this way, this is the explanation of the question. And like how we are going to solve this problem is, like first we will run one loop, and it will be pointing to each index. So suppose I is present at any particular index, and then we will just iterate whatever the length of this words array is. So in this case the length is 6 total, and we will iterate by 3 indexes. Like if we are present at this, then we will check what is this substring from this index to the next 3 indexes. So this is foo, so this is matching. So we will we will maintain a map in which we will also maintain the count of each and every string, and we will keep on decrementing this. If the value is found, then we will keep on decrementing, and if some value, some string count becomes 0, then we will remove it from the string, from the map, and at last we will check if this map is empty, our current map, then it means that all the words have been covered and we can add that index into our answer. So this is the explanation of the code. Let's see how the code is working. So we are defining, so we are given the string s and the words string. So first of all, we are defining n as the words dot size, this words dot size, and we are defining len as the s dot length, and then we will define word length as the words 0 dot length. So first word length is word length. Then we will initialize lnr to 0, and then we are setting temporary n is equals to n, and then we are calculating the required length, that would be n into word length. In this case it was 2 into 3, so 2 into 3 will come out as 6, so required length would be 6. And then we will maintain two maps, like it will have string as a key and integer as a value, and initial map and current map will be two map. And then we are also defining one string map, and this vector int is our answer. And this is some edge case, we will see this code later on. Let's first see the main code. So we will start iterating our words array, and we will increment the value of words count into our initial map. So initial map here in this case will contain foo will contain value 1 and bar will contain value 1, and then we'll define our flag as 0, and current map will be equals to initial map. And then we'll iterate from I is equals to 0 through len minus word len, and for each I will check like whether there is a concatenated string substring forming, and if it is forming then we will push it into our answer, otherwise we will not push. So for each iteration we will define int j is equals to 0 and flag would be 0. And now we are we will just iterate up to required length, because in this case required length was 6, so j will be incremented from 0 to 6. And then we'll check the substring. So initially j was 0, so we will take the substring of word len and we'll store it into our temp, and then we'll check if it is not found into our current map, then we will break out, because it means that this current index cannot be our answer, otherwise we will decrement this temp value and we will set this flag as 1. This is keeping count that this current map has changed. So if this flag becomes 1, then we will update our current map to initial map. So this flag keeps track of, like I can write it down also, keeps track of whether current map has changed. So now if current map temp count becomes 0, then we will erase this temp, and then we will increment j by word len. So in this way, like if at last this current map becomes empty, then we will push I into our answer, and if flag is 1, then this means that current map has changed, and we will again set current map is equal to initial map, and then we will finally return our answer. Now let's see what is this edge case. So edge case is if all words are same, and in this also all alphabets are same, and this word length is also 1, then we are handling it differently, because in that case there will be lots of answers. So we are initially defining all words same is equals to true, and we are checking words I is, if it is not equals to words I minus 1, then we will set all words same as false and we will break out. Now we are checking all characters same, now we are checking in this, and if s of I is not equals to s of I minus 1, then all characters same is equals to false, and then we will break out. So now we'll check if all characters same, if both of these booleans are true, and word length is equals to 1, then we will just push our answer from I is equals to 0 to len minus required length, because all of them will be our answer, and then we will return our answer. So in this case we are just handling the edge case, and let's try to run this code now. So yeah, it is getting accepted here. Let's try to submit it as well. So this is just failing in one test case, like 181 test case are getting accepted out of 182. So this is just failing in one test case. I think we can handle this test case in the edge cases only, and it will work fine. But otherwise, like you can see, 181 test cases have passed out of 182. Only one test case has failed, and like we can handle it in our edge case. So that's not an issue. Like although this is a hard problem, so usually hard problems don't have that much straightforward solution. So one test case is failing, and we can handle it in our edge cases. So like when I had sold, then all test cases were getting passed, but now I think they have changed some test cases, so that is why one test case is not getting accepted. But yeah, like this is more or less this is the idea, and this is the main idea. Like leaving these edge cases, this is the main idea which we will be implementing, and in interview also this approach should work fine. So yeah, I think you have understood the explanation of this question. So let me know in the comment section whether you have understood, or whether there are any places of improvements for me where I can improve. So let me know in the comment section. And if you found this video helpful, then also let me know in the comment section, and like this video and subscribe to my channel, and stay tuned for more such important top interview 150 series of questions. So thanks and have a nice day.